Have you ever wondered how your headphones work, or how a giant crane can lift a car? The secret isn't magic. It's something called the magnetic effect of electric current. And today we're going to break it down in a way that's super easy to understand. Let's start with a simple wire. When an electric current, which is just a flow of tiny charged particles called electrons, passes through this wire, something amazing happens. It creates an invisible field around it, a magnetic field. This discovery was made by a scientist named Hans Christian Ørsted back in 1820, almost by accident. He noticed a compass needle twitching whenever he turned on a nearby electric circuit. Why does a compass needle move? Because it's a tiny magnet, and it's reacting to the new magnetic field created by the current. This tells us a fundamental rule. Moving electric charges create magnetism. No current, no magnetic field. More current, a stronger magnetic field. It's that direct. So how can we visualize this invisible field? Imagine the wire as the center of a series of circles, like ripples in a pond. These are the magnetic field lines. We can use a simple trick called the right-hand grip rule to figure out their direction. If you point your right thumb in the direction of the current flowing through the wire, your fingers will naturally curl around it. That curl shows the direction of the magnetic field. Pretty cool, right? Now a single straight wire creates a relatively weak magnetic field. How can we make it stronger? Simple. We coil the wire up. This coiled wire is called a solenoid. Think of it like taking a long piece of string and wrapping it tightly around a pencil. When current flows through this coil, each loop creates its own magnetic field. Inside the solenoid, all these individual fields add up, creating a much stronger and more uniform magnetic field. It's like a whole team of magnets working together. And here's where it gets even more powerful. If we place a piece of iron like an iron rod inside this solenoid, we create an electromagnet. The iron core becomes strongly magnetized by the field from the coil, and this boosts the overall magnetic strength immensely. This is the principle behind those massive cranes in scrapyards. When the operator wants to pick up a car, they switch on the current. The electromagnet becomes super strong, and it latches onto the metal. To drop the car, they just switch the current off. The magnetism disappears instantly. This ability to turn magnetism on and off is incredibly useful. It's the basis for so many things we use every day. Motors in your electric fan or your blender use the interaction between magnets and electromagnets to create motion. Doorbells use an electromagnet to strike a chime. Even the speakers in your phone or headphones use a rapidly changing electromagnet to vibrate a diaphragm and produce sound waves. It's all thanks to this fundamental connection between electricity and magnetism. So, to recap, an electric current creates a magnetic field. We can make this field stronger by coiling the wire into a solenoid, and even stronger by adding an iron core to make an electromagnet. This simple principle is one of the cornerstones of modern technology, powering everything from simple household gadgets to massive industrial machinery. The world as we know it literally runs on this invisible force. I hope this helped you understand the magnetic effect of electric current a little better. It's a fascinating topic with endless applications. If you enjoyed this video and learned something new, please hit that like button and subscribe for more simple science explanations. Thanks for watching, and see you in the next one.